Okay. Hi, welcome back. And today I'm going to be solving the USACO 2016 January contest. So for problem one, angry cows. So Bessie the cow has designed what she thinks will be the next big hit video game, Angry Cows. The the premise, which she believes is completely original, is that the player shoots cows with a slingshot into a one-dimensional scene consisting of a set of hay bales located at various points on a number line. Each cow lands with sufficient force to detonate the hail bales in close proximity to her landing site. And the goal is to use a set of cows to detonate all the hail bales. And there are n hay bales located at distinct integer positions x1 all the way to xn on the number line. If a cow is launched with power r landing at position x, this will cause a blast of radius r, destroying all hay bales within the distance x minus r to x plus r. And a total of k cows are available to shoot, each with the same power r. So please determine the minimum integer value of r such that it is possible to use the k cows to detonate uh, every single hay bale in this scene. And the first line of input contains n, which is less than 50,000, and k, which is less than 10. And recall that k is the number of cows available to shoot. And the remaining n lines contain integers x1 to xn, each up to 1 billion. And please output the minimum power r with which each cow must be launched in order to detonate all the hail bales. Okay, so what is this problem asking? Well, there are going to be a bunch of hay bales, and here in this problem, there are going to be 7 of them. And each of these hay bales are going to be like on a number line, and they're going to occupy a specific position. So this hay barrel, hay bale, huh, is at position 20, and this one is at 25, this one's at 18, and so on. And then what we want to do is we basically want to launch um a certain amount of cows so that we explode or get rid of all the hay bales. And each cow destroys all the hay bales are positions in front of it and are positions behind it. And right now we have 2 cows available to shoot. So first I'm going to use a spreadsheet to test the sample input and see if the sample output is actually 5. Let's open this up. Oops, that is not the right one. Okay, okay. Anyway, so there are 7 bales, and there are 2 cows in total. And they're going to occupy positions 1, 3, 10, 8, 18, 25, 20. Now, this data is sort of a mess, so for now, let's just sort it so that it's a lot easier to work with. So first of all, I'm going to make the grid um, smaller. Give me a second here. Okay. Okay, this is good enough. So there are 7 bales, and there are 2 cows. And there are indexes. I'm going to place them all the way up to 25. Okay. And so first of all, there's one at index 20. So let's color this in. Let's color it in red since we want to get rid of these. And there's one at 25, one at 18, one at 8, one at index 10, 3, and 1. Okay, so according to the sample output, if we have a cow of power 5, we can detonate all the bales. So when we look at this in one picture, we can see that these 4 cows are pretty close together, and these 3 cows are pretty close together. So let's just try putting, try shooting the cow somewhere in between. So let's say that one cow is fired here at a green index, then it would need a power of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, in order to detonate all of the hay bales. Oops. Needs a power of 5. And if there was another cow, let's say here, then it would detonate all the cows in this area with a power of 1, 2, 3, 4. So a power of 4. So since we can only shoot 2 cows, which is the value here, k, that means the power has to be 2 in order to solve this. So yeah, the power has to be 5 in order to solve this. So yeah, the output is 5. So how can we solve this? Well, we recall first of all that in this problem, what we're actually looking for is the power r. And the amount of cows are always set, and we're just going to be trying to find the most optimal way um, to place each cow and the minimum amount of power that each cow requires. And one really easy way we can do this is by using um, a binary search algorithm, which is going to find the most optimal value or the lowest value of R that works at a very fast rate. So I've covered the binary search algorithm a lot of times in other videos, but I'm going to go over it again. So basically, we're going to have an integer low, integer high, and an integer middle. And what we're doing is we're going to be checking all integers that could possibly be the answer, starting from the middle. And then after we have this middle number, we're going to check if this middle number or if this power r successfully detonates all hay bales with less than or equal to k cows. And if it does, then we know that we can decrease the value of r, since we're trying to find the minimum value of r. But if not all the hay bales are detonated, or there needs to be more cows, then what we can do is we can increase. We can look for higher values of r, because we're going to need to have more power in order to detonate all the hay bales. So this is our lowest integer answer possible, and this is our highest integer answer possible, and we have the mid. So and then what we do is while low is less than or equal to high, which is basically it means that it's going to stop running when the low and high ranges narrow down to one value. So mid equals low plus high divided by 2, and this finds the average of low and high. And if check mid, and we're going to create a separate function for that later, then answer equals mid, answer equals the integer middle, and then we're going to decrease the range from all numbers to all numbers less than mid. If it's not, we know we need to increase the value, the middle value. We know we need to have a higher answer, so we do low equals mid plus 1, because we know that all numbers less than mid wouldn't work for the solution. and at the end you just print answer. Oh, and this is low equals mid minus 1. Wait, I'm sorry, this is high equals mid minus 1, and this is low equals mid plus 1. Okay. And now the only problem is how are we going to code the check portion? Boolean check. Well, what are we doing here? So what this function basically takes in is the set amount of power that we're allowed to use. So what we can do is we can optimally place cows with this amount of power and then see if the amount of cows we need to use is greater than the value we are allowed to use, which is k. And one way we can do this is by looking through each of these values and keeping track of when keeping track of the index of the last cow that was detonated. So let's say that the number of cow requires at first is going to be default set to 1, and I'll explain that later during when I finish coding this. And then the starting hay barrel that we're going to be looking at is going to be the first hay barrel. So in start equals index of the first hay bale. And then for each of the hay bales, what we're going to be doing is the index of the hay bale minus the index of minus start. So if the index of the hay bale and the last hay bale placed have a distance greater than the amount of power times 2, this looks a little bit confusing for a minute, so I'm going to explain it. So we're going to have a bunch of hay bales, right? And each of these, if we want to if we want to see how many cows we need to detonate all the hay bales, what we can do is we can keep track of this hay bale, and we know that each cow is going to have a total collective range of 2r, right? Since it's r radius behind and r radius forward. So what we can do is we can automatically add um, 2 times r to this very first index, which detonates all the hay bales in front of it, and then we can start a new like blast radius, I guess you could call it, which is going to be the most optimal way we can place all the cows with a certain power. So if the index of each if the index of the hay barrel minus the start is greater than the power times 2, which basically means that it's outside of the blast radius now. So the new hay barrel we're looking at is outside of the blast radius. Then we know that we are going to need another cow to take care of that hay barrel. And then start is going to be equal to the index of the current hay bale. And now cow plus plus makes sense because every time we see a cow that's outside of the blast radius, we need to add 1 to cow plus plus. And then at the end, we just return cow is less than or equal to k. Yeah, that's the basic algorithm. Let me move all of this over here. Okay, I'm going to start coding now. And hopefully, if you don't really understand this, it makes a lot more sense when I write it in code. So first, I'm going to be importing java.util and java.io. And I'm going to initialize the class. We need a buffered reader for the input, and we need a print writer for the output, and we also need a string tokenizer for the very first line, which is going to get the values of n and k, I believe. And integers are n, k, and we're going to need some kind of array to store all the indexes of the hay barrels, so we'll set that as a. And I'm going to be creating my main that throws an IO exception because we're using a file reader. The name of the file is angry.in. And it's angry.out, but for debugging purposes, for now, I'm just going to set it as .in input stream reader, which is used to access system.in. Then first we do our initialization, which is actually pretty simple for this problem. All we have to do is first we create a class. We get the values of n and k using a string tokenizer. We get the values of n and k. Yep, and then we initialize a. It's going to be length n. And for all of these values, a is going to be equal to a at index I is going to be equal to the next number in the input. And then we have to store a at the very end, right? In order to do the solve algorithm, the checking algorithm at the very end. Okay, well, after the initialization, we're going to be solving the problem. And we do this in a separate class. So we're going to be using the binary search algorithm we found here. So we set an integer low as 0, which is the lowest power that each cow can have if, let's say, there are no hay bales at all. And int high is going to be equal to let's see, it's going to be equal to n, which is going to be 50,000. No. So n is the number of hay bales. Okay. Okay, so if there are 50,000 hay bales, and okay, the hay bales can be at indexes 0 to 1 billion, right? Which means that the largest power we could possibly need would be 1 billion divided by 2. Because if we place a hay bale exactly in the middle of 1 billion, then it would have a maximum power of all the ones before it and all the ones after it. So it would be 1 billion divided by 2, which is 500,000, 500,000,000, 500,000, 500. Let's see. 500, we want to, oops, I forgot a 0. Yes, that looks about right. And we need a middle value, right? That's our algorithm. And we're going to need an integer answer, which is going to be what we output. While low is less than or equal to high, then we update the value of mid as the average of the two, and then we check mid using the function that we will create. And if this is the function works, then we can um, decrease the range we're looking for, since it's possible that we could accomplish getting rid of all the hay bales with a lower power, and else we do low equals mid plus 1. And we print out the answer. So now let's do the solve portion. Where it's going to be a function called static boolean check, and let's set the input integer as r, which is going to be the radius, or yeah, the radius of the blast. And first, we need an integer called cow, which is the number of cows we're going to use. Cow count actually, and we're going to need a starting cow, which is a at index 0. And for each of hay barrels, if the distance of that specific hay barrel and the last hay barrel is greater than the last radius times 2, which means it basically means we're going to need a new cow, and we have to update the value of start, which is the last cow, index of the last cow. In the end, we just return cow is less than or equal to k, and this should ensure they should check if the optimal way to place cows within radius of r does not exceed the value of k, which is the number of cows. So yeah, I'm gonna just try to use the sample input right now. Sample input. And that's a 5. I'm going to be submitting it now. Oops. And we also need to close in and close out. Okay, yeah. Try submitting it. Yeah. Hope it works. Nice. Okay, as you can see, it compiled in an extremely fast amount of time. Well, in Java anyway. And yeah, this is a really efficient way we can solve this problem using binary search. And yeah, I hope this video helped you guys understand this problem and how to solve it. And thanks for watching.